In this demo, we'll demonstrate how Elastifile supports true hybrid IT by enabling enterprise applications to seamlessly lift, shift, and go from on-premises environments into the cloud. Now, before diving into the demo, let's quickly review the details of what we mean by lift, shift, and go. First, we start with the file system. This could be any NFS-compatible file system, whether provided by Elastifile, NetApp, or some other vendor. We first select the data of interest. Then Elastifile's Cloud Connect capability efficiently compresses and deduplicates that data for transmission into the cloud. Also note that future transmissions will only send the deltas from the pre-existing state, resulting in a highly efficient, cost-effective data transfer mechanism. When data moves to the cloud, it is stored in cloud-native S3 object format, but retains the original file and directory hierarchy information, along with versioning information. We call this process the check-in process. The data can then remain in an inactive state in cost-effective object storage until needed for active processing. When active processing is required, the data can then be checked out into an Elastifile file system running in the public cloud. When processing is done, any updates can then be checked in to object format for cost-effective storage. In this particular demonstration, we're going to select data from an Elastifile file system supporting a VMware cluster, then transfer the data into the Amazon cloud, then check it out for processing using Hadoop MapReduce. First, we'll start with the 4-node Elastifile cluster supporting a VMware environment. Here you can see the nodes as set up in the vSphere GUI. Next, we want to make changes to data stored locally in our virtualized environment. To do so, we're going to select the file stored on the Elastifile file system and make some edits to that file, and then save the updates. Here you can see we've opened a pre-existing local document named Gutenberg.txt, and we're going to insert some new text into that document, electric fidget spinner. Next, we'll insert into a different portion of the document a second instance of that new text. As you can see here, again, the text is electric fidget spinner, and then we'll save those changes and persist them to the Elastifile file system. Next, we'll leverage Elastifile's Cloud Connect capability to efficiently check in our updated files to the public cloud, where they'll be stored in the very space-efficient, cost-effective S3 object format. Again, as we discussed previously, all files will be efficiently deduplicated and compressed before transfer, thereby minimizing both the cost of transfer and the time required for the transfer. Now here, as we move to the Elastifile GUI, you can see that we're going to select a specific combination of target service provider and source data. In this case, the service provider is AWS, and the source data is a set of local files, which include the Gutenberg.txt file that we modified previously. Here you can see the corresponding cloud-based S3 bucket associated with our target is named AWS Demo 1-David-Elastifile. And next we're going to go ahead and check in our updated files into the public cloud. As you can see, the check-in process completed successfully, and as we navigate to the AWS GUI, we can see that the updated S3 bucket is visible in the GUI. When clicking on the bucket, you can also view the S3 objects stored within that bucket. Data can remain in an inactive state in the space-efficient S3 object format for as long as the user desires. However, to demonstrate Elastifile's ability to support active data processing in the cloud, we're next going to check out our data into an in-cloud Elastifile file system running natively on 4 AWS instances. Here you can see in the AWS GUI that we have the Elastifile Cloud file system already set up on 4 cloud instances ready to run as a Hadoop cluster. Now we're going to select a desired combination of service provider and data source. The service provider is still AWS, but in this case, the data source is now the S3 bucket that includes the modified files that we checked in previously. We're going to proceed with the checkout process to check the data out from the S3 bucket and into the in-cloud Elastifile file system. And as you can see, the checkout was completed successfully. And now in the final stage of our demo, we're going to run an application in the cloud to process the data that we've checked out into our in-cloud Elastifile file system. Again, Elastifile can support any NFS application running in the cloud, but in this case, for our demo purposes, we're going to leverage the Hadoop MapReduce application. First, we're going to launch the Hadoop processes on our in-cloud Elastifile cluster. Then we're going to execute MapReduce jobs to perform a word count on the in-cloud directory containing our modified Gutenberg.txt file. Next, once the MapReduce word count processes are completed, we're going to analyze the resulting output files, searching for instances of specific targeted text. And the text we're going to look for is the new text that we inserted into our files when they were on premises, electric fidget spinner. Now, as you can see here, the two instances of our targeted text were successfully located by the MapReduce word count processing. And with that successful processing, we've now demonstrated an end-to-end lift, shift, and go workflow, beginning with the modification of local files on an Elastifile cluster located on premises, then the efficient transfer of those files into S3 object format in the cloud, leveraging Elastifile's Cloud Connect capability, then the checkout of those files into an in-cloud Elastifile file system, and finally, the successful processing of those files using an application running in the cloud on top of Elastifile. Thank you, and we hope you've enjoyed this demo.